this galvanometer, before we have seen the deflection in the galvanometer, but let us prove that a magnet can produce electricity by doing this experiment. So, in this experiment, this is the this is the bar magnet. So, now I am inserted the bar magnet, and while I am removing, friends, can you observe anything in the here? Friends, just observe that the lights which are presenting on the galvanometer is blowing. So, here the lights which are connected to the galvanometer is glowing. Why? Because when I am placing the magnet, just observe the light here. Why the light is producing means here the magnet is producing electricity. So, here this light indicates that here the magnet is producing electricity. Friends, have you observed the light on this galvanometer? Yes. Here now we also proved that a magnet can produce electricity by using the galvanometer. And friends, let me show what are the applications for this galvanometer. There are several applications of galvanometer in our day-to-day life. So, let us see what are the applications. Friends, all of you see here, what is this? Yes, here this is an electric generator. So, let me show the model of the electric generator, how it is working on the principle of electromagnetic induction. Friends, all of you see here, this is the model for dynamo or electric generator. So, in this electric generator, here inside the horseshoe magnet there is a coil, right? Are you able to see the coils? Yes, these are the rectangular coils which are presented between the horseshoe magnets. So, inside this red color coat, inside there is a horseshoe magnet. So, here again this is the wheel, right? So, here now I am started rotating the wheel. So, while I am rotating the wheel, here automatically the bulb is started glowing. Friends, are you able to see the bulb is glowing? The bulb is glowing? Yes, here the bulb is starting glowing. Why? Because whenever I am rotating the wheel, the coil which presents in the between the horseshoe magnet is rotating, and here it is creating electricity. Here there is a horseshoe magnet. So, between the horseshoe magnets the coil is producing electricity. So, due to that here the light is blowing. So, let me show once again. Again I am started rotating the wheel of this, and here the bulb started glowing. So, in this process we can easily say that this model is working under the principle of electromagnetic induction. Why? Because there is a horseshoe magnet and inside there is a coil. So, the reaction between these two, the current is inducing, and here the bulb is glowing. So, this is the best example for us to know that a magnet can produce electricity. And also let me show another application, that is a transformer. Friends, generally in our villages we will see the transformer, right? So, this is the transformer. This transformer is also works under the principle of electromagnetic induction, and here this transformer means nothing but it is an electrical device, and also generally in the transformer there are two rectangular coils, that is primary coil and secondary coil. So, for the primary coil there are only less turns of coil, and for secondary coil there will be more turns of a coil, and in this primary coil the current will induce and it passes this current to the secondary coil without contact with each other. So, due to this the transformer is working. So, here the transformer is also working under the principle of electromagnetic induction. And let us see another example, and one more interesting application is electric guitar. Friends, once all of you look here, this is the electric guitar. So, friends, do you know how this electric guitar is working under the principle of electromagnetic induction? Yes, here generally we may see the electric guitars in our day-to-day life. So, here for this electric guitar, these are the stringers. These are the stringers. So, when we pick up one string from this guitar, so automatically it produces resonance. So it produces resonance with equal frequency frequency of the string. So here this string produces resonance with equal frequency of the string, and also inside the electric guitar there will be one magnet. So whenever we pick up the strings of the electric guitar, automatically the magnet oscillates forth and back, the magnet oscillates forth and back, or automatically it produces electricity. So due to this it produces sound. And also let us see another example, that is microphone. Friends, normally we may use the microphones in our day to day life, right. So in this microphone also, whenever we talk, generally if there is any programs will be conducted in our schools or in any other programs, we use the microphones. So in these microphones, when we talk, there will be a magnet inside this microphone, and here when we are producing sound, that means when we are talking, automatically the magnet which presents inside the phone will oscillate forth and back, and due to this we can say that the microphone is also working under the principle of electromagnetic induction. And let us see another example, that is metal detector. Friends, generally whenever you go to a shop or any other jewelry shops and for any other big shopping malls, we can find this metal detectors. So while we are crossing through this metal detector, it gives a sound, right. So how this sound is producing, whenever if we carry any metals, that means any guns or like that, if we carry any metals, automatically the metal detector produces sound. Let me explain how the metal detector is producing sound. Here this is a metal detector, and he is the person who is crossing through this metal detector. Here in this metal detector there will be a coils. So whenever he carries any gun or like that, here this gun acts as a magnet. So due to this the metal detector produces sound. So this is also working under the principle of electromagnetic induction. Friends, today we came to know about so many things in this session. So let me explain once again what we have learnt in this session. So first of all, we came to know about magnetic flux, and there are so many applications of magnetic flux in our day to day life, and also we have seen the direction of the induced current by using the galvanometer. And also friends, all of you once look into this PPT. Here first of all, our concept is electromagnetic induction, right. So electromagnetic induction means here we have induced the current under the effect of electricity and magnetism. So it is said to be electromagnetic induction. And also friends, here needle deflected indicates induced current. That means here whenever we performed the experiment in the galvanometer, the galvanometer, the needle which presents in the galvanometer is showed deflection to us. That means the deflection is nothing but it indicates that current is induced in the coil. And also we came to know that EMF is directly proportional of the magnet. That means induced EMF, the magnitude of induced EMF is directly proportional to strength of the magnet. That means if we increase the motion of the bar magnet, that means if we increase the speed of the bar magnet, automatically the induced current is also increases. So that is why we told it as induced EMF is directly proportional to strength of the bar magnet. And also here we told that EMF is directly proportional to changing in magnetic flux. Yes, it is correct. Why? Because magnetic flux means what? Here while I have done the experiment by using the galvanometer, there I have changed the magnetic flux. So due to the changing in magnetic flux, the induced current is producing. So that is why it showed a deflection. That means deflection means nothing but it indicates that induced current is produced. And also we told that induced EMF is directly proportional to number of turns of a coil. That means here, and also before I also told that if we increase the number of the turns of a coil, automatically automatically the induced current is also increases within the coil, and also induced EMF is directly proportional to cross sectional area. That means if we increase the radius of the coil, then automatically the induced current within the coil is also increases. And in this session we have induced the current by using the magnet, and these experiments was performed by the great scientist Michael Faraday. And also we have seen some of the applications, right. So the applications are fast moving electric trains normally, which we may not see in our India, but which we can see abroad, and also induction cooker, and even a wireless charging. So all these kind of phenomena are getting possible only because of the phenomenon of electromagnetic induction. So and also we have taken a transformer as an example of electromagnetic induction, right. For this transformer we can take more example. For example, even a charger of a mobile is also acts as a transformer. And also why? Because transformer means nothing but transformer.
Hello.
Yes. Hello.
Hello. Good afternoon, sir.
Good afternoon, sir. What is your doubt?
Sir, I am from Akibal, B.Srividya, Dindi.
Okay.
Sir.
What is your doubt, Svero?
What is the electromagnetic induction?
Electromagnetic induction means nothing but here electromagnetic induction means to induce current, but that means what? Electromagnetic induction, electro plus magnetic plus induction, that means it is related to electricity, magnetism and induction. So here we have electromagnetic induction is nothing but to induce current under the effect of electricity and magnetism. Svero, is your doubt clear now?
Sir, I have one doubt.
Tell me, what's your doubt?
What is the magnet field?
What? Magnetic field. Yes, magnetic field means nothing but magnetic field is the strength of the bar magnet. For example, this is a magnet, right. So see, let me show what is magnetic field. Magnetic field means nothing but the strength of the magnet. For example, if you take a bar magnet, it attracts the metal. So here this is the metal. Here this is the metal. So here this metal is the attraction power. That means there will be the magnetic field created around the magnet. So unless till how much the magnetic field is, then only the magnet attracts the metal. So if there now I have placed the bar magnet here, and then here it is a metal. So there is no attraction. That means the magnetic field is less. So when I take the bar magnet near, automatically it attracts. Why? Because due to magnetic field, there is a magnetic field around the bar magnet, and due to this the magnet is attracting the metal. Okay, friend. And also in this session we came to know about Michael Faraday. He was a great scientist. Really we have to appreciate the experiments which is performed by the Michael Faraday. Why? Because even today we are. Yes, friend, what is your doubt? Hello.
Hello, good afternoon, Svero. I am G. Anusha from Adilabad district.
Okay, Svero, what is your doubt?
When we are keeping the magnet in the copper foil while the needle is moving.
Why the needling? Okay, let me show once again. I think you are not clarity about this experiment. So here this is the bar magnet, right? So when we are inserting the bar magnet, so now in what pole I am inserting? This is the north pole. So right. So while I am inserting the north pole while I am inserting the north pole, it showed deflection. While I am inserting the north pole, it showed deflection towards right. Why it is showing deflection means here this is the copper coil, right. So and this is the bar magnet. So when I inserting the bar magnet, here this bar magnet when we insert the bar magnet inside the coil, here the current is inducing. So that is why here the deflection in galvanometer is nothing but it shows that current is inducing in the coil. So if there is no current, if now I kept the bar magnet stationary, is there any deflection in the galvanometer? There is no deflection. Why? Because here no current is induced. Whenever the current is induced, then only it shows the deflection. Are you clarified, friend? Okay. Now we are talking about Michael Faraday, right? So, Michael Faraday is a great scientist. Why? Because really we have to appreciate him. Why? Because even today in this generation we are feeling all the comforts only because of the great scientists like Michael Faraday. So, all these great scientists have performed several activities to make our life better by using all these things and by applying all these things in our day to day life. And also friends, and also I would like to say one thing, and I would like to show one thing. First let us see on the PPT here exam point of view. That means I would like to suggest you that maybe some I will give you some questions. So, you should be aware of all these questions, and these questions may be expected for our public exams. Why? Because exam point of view means we have now this according to the CC model. Friends, okay friend, what is your doubt? Hello? Hello? What is your doubt?
Good afternoon, sir.
Good afternoon. What is
Good
your
afternoon,
doubt?
sir.
Good afternoon.
This is Shravya from Adore School.
Okay, Shravya, what is your doubt?
Did you explain the electric flux?
Electric flux, okay, exactly. Friends, before we came to know about magnetic flux, right? So, electric flux is also nothing but in the magnetic flux, what I told, magnetic flux means the number of magnetic fields which are passing through particular area. So, let me show here. Magnetic flux means nothing but these are the magnetic field lines, right? So, in this magnetic field lines, here this is the particular area. Sorry. Okay, this is the area vector. So, these are the lines which are passing through the area vector. So, here what I told, magnetic flux means nothing but magnetic flux means the number of magnetic field lines which are passing through particular area. So, similarly, electric flux is also nothing but electric flux means the number of electric lines or number of electrons which are passing through particular area is said to be electric flux. Friend, are you clear your doubt? Hello?
Hello.
Okay friend, what is your doubt?
Sir.
Yes.
Hi, sir. I am from Asifabad.
Okay, what is your doubt,
So,
sir?
I have one doubt.
Okay.
Is magnetic field or line are closed?
What?
Is magnetic field line are closed? Why?
Magnetic line. Oh, here the I actually I may don't know exactly what the answer for this. So, if it is possible, let us discuss in the next session, right? Okay, friend. Hello.
Hello?
Hello, friend. What is your doubt? Hello. Hello, Swero. Okay. Let us see what is exam point of view. So, here I bought some questions for you. Let us see on the PPT. Here, state Faraday's laws of electromagnetic induction, and the next is describe what happens when a bar magnet is pushed into or pulled out of a solenoid connected to an galvanometer. Draw pictures to support your description. And what is transformer? How is it work based on the principle of electromagnetic induction? So friends, and now we also came to know about exam point of view. Hello? Hello? Hello, Swero? Okay. Today, actually, I think you have understood. I think by my class you have understood several aspects on the concept of electromagnetic induction, and also make use all these applications in our day to day life, and also hello. 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 Okay.
Hello.
Hello, Swero.
Hello, I am Vaivendra Sparrow from Adilabad district.
Okay, Swero, what is your doubt?
Hello, I am Vaivendra Sparrow from Adilabad district.
Okay.
My question is,
Okay.
what is the relation between electricity and magnet?
Yes, good question. Yes, the relationship between electricity and magnet means nothing but here, for example, before only in the starting of the session, I told that there is a good relation between electricity and magnetism. For if you take a coin, for a coin, how there is a heads and tails, like that here there is a good relation between electricity and magnetism. So here there is one Oersted experiment. He proved that electricity can produce a magnet, and he also told that every current carrying conductor acts as a magnet. So here this is the relation between magnet and electricity. What it means? Electricity can produce magnet and magnet can produce electricity. Friend, are you clear? Okay. Hello.
Hello, I am B. Sparrow from Adilabad district.
Okay, Swero.
Hello, I am B. from Adilabad district.
Okay.
Can you explain the Fleming's right hand rule?
Okay, definitely. So, let me explain this Fleming's right hand rule. See here, this is the Fleming's right hand rule, right? Here, this is my thumb finger, forefinger and middle finger. So, here Fleming's right hand rule, why we are using this Fleming's right hand rule means, by using this Fleming's right hand rule, we can know the direction of the induced current. Here, my thumb finger indicates the direction for the motion of the conductor, and here forefinger indicates the direction for magnetic field, and here finally the middle finger indicates the direction for the induced current. So, this is the Fleming's right hand rule easily which we can know the direction of the induced current. Friend, are you clear your doubt?
Where we use this rule?
Okay, good question. When we use this Fleming's right hand rule means, if we want to, whenever we have to know the direction of the induced current only in the straight conductor. For example, if we take any straight conductor, so in that by using this Fleming's right hand rule, we can know the direction of the induced current. Is it clear?
Yes, Swero, thank you.
Thank you. Hello.
Hello.
Hello. Swero, tell me.
Hello.
Yes.
Hello, Swero.
Yes.
This is Manohar from Rajapet.
Okay.
How the Faraday law
Please reduce your TV volume.
is useful?
Once again, please repeat your question once again.
How the Faraday law is useful?
Faraday law. Yes, we have given so many applications, right? There are so many applications for this Faraday law, and I have showed the example of here. See, all of you see here. One, see here. This is the model for dynamo or electric generator, right? So, in this generator, here the Faraday principle is involving in the working of this generator or dynamo. So, here these are the coil. Inside this is a coil. So, for this coil inside there are horseshoe magnets in the two sides. So, here while I am rotating the wheel. So, while I am rotating the wheel, automatically here the current inducing. So, friend, are you clear to see the light is glowing in this? Yes. Here the light is glowing. Why the light is glowing? It is nothing but here the coil is producing, here the electricity is induced within the coil. That is why the light is glowing. Friend, are you clear your doubt?
Thank you, sir.
Okay. Hello. Hello.
Hello.
Yes, tell me.
Hello.
Yeah, tell me what's your doubt?
Hello, sir. Good afternoon.
Good afternoon.
This is Kishore Sharra from Asibad Adilabad.
Okay.
Can you explain which principle used in electric bulb?
Electric bulb. Yes, actually for the glowing of electric bulb is also Michael Faraday was used magnet, right. Before I told one example, that is if we take an electric bulb and magnet, the two terminals of the, if we connect the two terminals of the electric bulb to the two ends of the bar magnet, automatically the bulb started glowing. So, due to this experiment only the Michael Faraday was discovered that a magnet can produce electricity. So, here by using the purpose of magnet also electricity can produce in the electric bulb. Is it clear? Okay. So, I am really very lucky to have this chance for me to teach in this Mana TV session, and also I thankful all my teachers and friends who have cooperated me to put my efforts and they have performed so much of hard work towards me. So, thank you for giving this golden opportunity for me. Thank you once again.